Hello, everyone. Welcome to the EBTC webinar. We will give 1 more minute for everyone to get in. I see that a lot of people are logging in right now, but we will start at 8:01 this session, sorry, 11:01 this session, because we want to make sure that we have enough time for discussion at the end. Okay, let's get started. Hello and welcome everyone to the EBTC GRADE webinar. The topic of the webinar is how certain are we? The progress in adaptation of systematic frameworks for environmental risk assessment. And first, let's start with logistics. If you have questions to the panelists, please use the Q&A. The chat function is going to be disabled. And this webinar is recorded and is going to be available on the EBTC YouTube channel, which we will inform you about when we upload the recording. And if you have any technical issues, please email Camila, who is our wonderful program coordinator, and her email is displayed on the screen. With that, I would like to start the session with a brief introduction to the context. We will display the questionnaire so that we know which expertise you bring in and what you want to get out of this webinar. So this is the agenda for session 2. We just finished the session 1 that was focused on mechanistic evidence. I'm delighted to have all the speakers present their perspectives on how they assess the certainty in environmental health context. So it's quite a diverse group of speakers. I'm really excited to hear about this. So I'd like to say a few words about GRADE working group. So GRADE stands for Grading of Recommendations, Assessment, Development, and Evaluation. And this is an approach for assessing certainty of evidence and strength in the recommendations. That's over 2 decades old right now, and it's adopted by over 100 organizations worldwide. It started its application in the field of medicine and public health. But since 2015, there is a GRADE environmental and occupational project group that's devoted to furthering methodological efforts of evidence assessment and decision-making in environmental health.
Katja, I'm ending the poll.
Thank you, Camila. So the poll will be shared with everyone. So I'm seeing that there is a majority of us are in risk assessment, and we have more people here in systematic review methodologists and adverse outcome pathways. We had about equal in the first session. Interesting. Thank you so much. So now a little bit about EBTC. So evidence-based toxicology collaboration is a collaboration of science, regulatory, and industry leaders that is united by a vision to bring evidence-based toxicology and systematic reviews to become the standard that's used to ensure public health, healthy environment, and sustainable future. So EBTC is trying to be that platform and honest broker between various stakeholders to help harmonize and foster the discussions between different scientists and scientific disciplines and stakeholders in this field. So there is a statement about funding and the conflict of interest. And we are at Johns Hopkins Bloomberg School of Public Health. So EBTC is governed by the Board of Trustees that also is striving to achieve the balance of various stakeholders. And we have a staff of 5 people who are all listed here. And the organizer of this seminar and moderator is Paul Whaley, who is EBTC Research Fellow and also is at the University of Lancaster. So the EBTC work is organized in 2 buckets. So it's the methodologies and practical applications. The practical applications are systematic reviews that we're conducting and supervising. And we also work on methodological issues of applying systematic reviews to the field of toxicology. So the systematic reviews in toxicology is rather new. And as you all know, randomized controlled trials in toxicology are rarely possible for ethical reasons. And there is a very heterogeneous evidence base in toxicology that includes various species of animals and new scientific methods such as in vitro, stem cells, organ on chips, and more in silicon computational methods. So there are new tools that are tailored to this type of evidence that are needed, and that's a big part of what we're working on, and that's what we're going to be talking about today. So the systematic review in environmental health really has started developing in mid to late 2000s, and Dr. Thomas Hartung, who is managing the Department Center of Alternative of Animal Testing at Johns Hopkins and is a professor of evidence-based toxicology at Johns Hopkins School of Public Health, has convened the first international forum towards evidence-based toxicology in 2007 in Como, Italy. And in 2011, evidence-based toxicology collaboration at Johns Hopkins School of Public Health has been started also by Dr. Hartung. It's worth to note that in 2010, the first agency that started using systematic reviews in their risk assessments is European Food Safety Authority. And following that, there is a number of authorities that started using this approach or piloting using this approach, such as National Toxicology Program in 2014. And the EPA started looking at using this approach in 2015. In 2017, EBTC has convened its stakeholders to write a primer on evidence-based reviews, on systematic reviews in toxicology. And the same year, EFSA and EBTC conducted a colloquium on evidence integration in Lisbon. It's the work that has been picked up by National Academy of Sciences that had a workshop last year on evidence integration in toxicological research. So last year, there were a few workshops that EBTC has convened, which is the Toxicology Journal Editors Workshop, working on consensus statement on systematic reviews. And the two other workshops that are directly related to today's topic are the one that convened in Hamilton last year, preceding the annual GRADE Working Group meeting, where we had 34 people participating, and then in small groups, a small group discussion, over 100 people participating in the main GRADE meeting. There were 4 themes that were discussed at this meeting, and this was, as far as we know, this was the first time when the AOP community met with the systematic review community, which are very different universes, which was a very interesting discussion. In fact, we had so much fun that we decided to reconvene in about 3 months in October in Parma and continue those discussions. So, and that's what really led to some of the collaborations and publications that have started coming out from this work, and that's what led to this discussion. So we just finished the first session on incorporating of mechanistic data in systematic reviews in environmental health this morning, which was very interesting, and I'm looking forward to the current session. And I'm on the wrong slide, and I'm giving the floor to Paul.
Lovely, thank you very much, Katya. Yes, so it is my pleasure to introduce our first speaker, who is Dr. Frank Pega, Technical Officer at the Department of Environment, Climate Change and Health at the World Health Organization headquarters in Geneva. And he's going to be talking to us about WHO experience in adapting the GRADE framework to assessing certainty of the evidence in systematic reviews of prevalence studies. Frank, if you'd like to share your screen. And I will give you a 3-minute indicator by dinging this glass I have on my table, okay?
Super, thank you so much.
Okay, so please take it away.
Okay, lovely. Well, first of all, thank you again, Paul, for this lovely introduction, and also for to you and the organizers for inviting me to this session, which I'm very excited about. Okay, as Paul kindly introduced, I will talk about an approach that we have developed for assessing the quality or certainty of evidence in prevalence studies of exposure to occupational risk factors. And I noted the survey that was conducted just before, and that many are interested in health risk assessment. And so I guess this approach that we are proposing here, this emerging approach, is certainly very relevant to exposure assessment steps of this approach. Before I start off, I wanted to thank my colleagues at WHO who have also participated in this approach development, Susan Norris, who's online, and Richard Brown, who I've both seen. But also I wanted to thank the WHO working group that has actively participated in this work, including Rebecca Morgan, who's online, and also Nicholas Chartres. Colleagues, in this presentation, I want to do the following things. I want to provide an overview of the WHO ILO Joint Estimates, which are basically the motivator that got us to develop this emerging approach. I want to talk about the systematic reviews of prevalence studies in occupational health that we're conducting as the base for producing joint estimates, joint global health estimates with the International Labour Organization. And I will then quickly introduce the emerging QSPO approach, how it's developed based on GRADE, and what its key 3 steps and components are before I finally draw some conclusions. Okay, what are the WHO ILO Joint Estimates? Well, the World Health Organization is the UN specialized agency responsible for health, and the International Labour Organization is the specialized agency responsible for labor, have decided in 2016 to join hands and for the first time develop joint estimates of the work-related burden of disease and injury. These are the WHO ILO Joint Estimates. This is very exciting because previously WHO and ILO developed estimates separately, and there was some policy incongruence, and that will be resolved by us producing joint estimates. As part of this process, we have, as organizations, decided to conduct 15 systematic reviews in meta-analyses that will basically provide the required input data and other evidence for producing these joint estimates. These are and will be published in a special issue in Environment International, to which Paul Whaley is the handling editor. So we greatly appreciate that link and that support. Currently, there are about 200 individual experts in 35 countries who are actively participating in the development of these this series of 15 systematic reviews. So it's a huge effort, and specifically, it's important to note that there are 5 systematic reviews that are being conducted on the prevalence of exposure to occupational risk factors. And these are, in essence, colleagues, the systematic reviews that I want to talk about today.
Dr. Frank,
Yes.
I see your video is off now. Your connection is a little bit delayed, so just keep your video off.
Okay, thank you. Colleagues, first of all, it's important to note what we mean when we talk about prevalence studies of occupational exposures or exposure to occupational risk factors. So prevalence studies are basically those that determine if an exposure is present or not, if the exposure to a specific risk factor, in our case occupational risk factor, is present or not in an individual of a study population at one point in time. So in essence, we're talking normally about cross-sectional capture of a specific exposure. So prevalence can then be calculated simply by dividing the number of exposed persons by the total number of persons in a specific study. And therefore, usually prevalence is reported as a percentage. So an example would be 85% of construction workers in a specific workplace setting in a particular country are occupationally exposed to noise. What's important to note is these prevalence studies, while they might seem quite banal and they're the basis of many investigations and many surveys, they are actually quite different to studies of effects in the way that and one determining factor is basically that they can be highly heterogeneous. So there can be a lot of variability in exposure to occupational risk factors, both within a specific worker or also between workers. For example, for construction workers, it's quite imaginable and it's quite likely that a construction worker might be exposed to occupational noise on one day, but not on the next. And also workers working in different occupations or different industrial sectors might have different levels of exposure to occupational noise. The WHO ILO systematic reviews of prevalence studies are listed here for you. As I mentioned before, we're currently conducting 5 of these, and you can see they basically concern a broad range of different occupational risk factors, ergonomic risk factors. We're looking at the prevalence and level of occupational exposure to 3 dusts and fibers, silica, asbestos, and coal dust. We're looking at exposure to solar ultraviolet radiation at the workplace, to occupational noise, and also to a psychosocial occupational risk factors, a risk factor which is long working hours. When we started developing the methods for these systematic reviews, we realized quickly that currently there seems to be no standard approach for assessing quality or certainty of evidence in these prevalence studies. So as an attempt to address this methodological gap, we started developing the QSPO approach. As I mentioned previously in the introduction, this is clearly based on the GRADE framework. We have looked through the standard downgrade domains of GRADE, and you will see shortly that we have adopted all 5 of those. We have looked to GRADE for any upgrade domains that might be relevant to assessing prevalence studies in occupational health, but found that none of these were applicable, which I will talk about a little bit more in a second. We also realized that to assess certainty in prevalence studies in occupational health, we certainly needed a new step, an upfront step, to assess what we coined as expected heterogeneity of exposure to an occupational risk factor. So something that, to our knowledge, hasn't previously been done a lot in assessments of certainty of evidence. We then developed our emerging approach. We have a document that basically outlines exactly, that guides assessors through this approach. We pilot tested it on one body of evidence from one of the WHO ILO systematic reviews, and then subsequently, in the absence of any other standard approach, applied it in our 5 systematic reviews. Let me quickly introduce the 3 steps of QSPO. First of all, we judge the level, or an assessor is asked to judge the level of expected heterogeneity, and I will show on the next slide how. Then we assess, or each individual assessor assesses along downgrading domains. And then assessments of individual assessors are brought together to arrive jointly at a final decision, a final rating on the certainty of evidence across all involved assessors. Here's some more information on the first step to judge the so-called expected heterogeneity. The definition that we coined for expected heterogeneity is the variability that is real and non-spurious in the prevalence of exposure, both within or between, well, either within or between workers or both, right? So it's sort of the idea behind it is basically that, as I mentioned before, there could indeed quite likely be some heterogeneity within or between workers, and that needed to be assessed first. And you see below how we are currently conceptualizing this. There are two questions that the assessor asks after being provided some considerations for how to assess. The first is they are asked to say if they reasonably expect the prevalence of the risk factor to be heterogeneous, where you can see that there are two ratings, no or only minor expected heterogeneity or some heterogeneity expected. And then in the second step, in the second question, the assessor is asked to rate the actual level of heterogeneity, if there is any, from low, medium, or high as the three rating choices given. Then in the second step, this is probably what everybody is very familiar with, assessors assess along the 5 downgrade domains of grade. So they assess risk of bias in the entire body of evidence, indirectness, inconsistency, imprecision, and publication bias. I wanted to note that risk of bias assessments are based on a new tool that we've developed for assessing risk of bias in exactly this type of studies estimating prevalence of exposure to occupational risk factors. So we now also have a tool at hand specifically tailored for occupational health assessments for risk of bias. Right? Another set of methods that we've developed specifically for our systematic reviews of prevalence studies. However, what's important to note is quite different is the assessment of downgrade domains or long downgrade domains with regards to the level of expected heterogeneity. So we consider the ratings from step 1 of expected heterogeneity now in step 2, specifically for the domains of inconsistency, unsurprisingly, but also imprecision. And colleagues down here, I note one specific example where assessments of inconsistency are different according to whether I have assessed the level of expected heterogeneity as low, or in this case here is moderate or high. So let's play it through. If an assessor has rated the level of expected heterogeneity as moderate or high, when they assess inconsistency in the total body of evidence, if they do find that the body of evidence is indeed quite homogeneous, then there might need to be the need to downgrade, because indeed we expected heterogeneity to be high. So we expected the body of evidence to be heterogeneous, but we found it to be homogeneous. So there might be some issue and our certainty might be reduced as a result of this. It's surprising.
You have 3 minutes.
Perfect. Okay, thank you. It's surprising because normally, of course, we wouldn't expect that. And also, similarly, if the body of evidence is indeed heterogeneous, as we have anticipated, then we wouldn't proceed to downgrading. Finally, the final decision, final rating on the quality of evidence across assessors is again very similar to what you're used to in GRADE. So all assessors basically agree on one rating for each downgrade domain, and then jointly come to a final conclusion with the ratings here shown in the table. And you can see the explanations of the ratings are indeed very similar to those in GRADE, so moderately modified. Let me in time draw some final conclusion. WHO, with the help of several individual experts that I mentioned up front, some of you are in the call today, thank you very much. We've jointly developed this emerging QSPO approach to assess prevalence studies of exposure to occupational risk factors based on the GRADE framework. As I outlined, QSPO has 3 steps. We assess expected heterogeneity, we downgrade along the grade domains, grade downgrade domains, and we reach a final decision with all assessors by consensus. The innovative features of QSPO are listed here again. So there is an upfront assessment of what we have coined expected heterogeneity. It's unusual. And then also assessments of selected downgrade domains are essentially based on the level of expected heterogeneity. And also, colleagues, thirdly, there are no upgrade domains in QSPO. Finally, just to note that QSPO has been pilot tested. It has been used already in WHO's and ILO's 5 systematic reviews of prevalence studies, but clearly it's an emerging approach. It's sort of at the proof of concept stage, or perhaps a little bit more than that, and requires further development and testing. And colleagues, with this, I would like to thank you very much again and look forward to questions. Thank you.
Excellent, thank you very much, Frank. I don't see any questions yet in the question and answer panel, so if any participants do have questions, you can ask them through the Q&A button at the bottom of the Zoom display. So I guess I get to ask a question. So Frank, could you just clarify a little bit more the role that existing GRADE working group members have had in developing the QE SPE approach, and then maybe what plans you might have in future for maybe integrating the GRADE working group perhaps into further development of this, because it is a new concept and an adaptation of the GRADE framework. So it'd be interesting to hear about that.
Right, thank you very much, Paul. Well, I have to admit that I'm not 100% familiar with the membership of the GRADE working group, but I believe that Rebecca is one of you. So Rebecca Morgan's certainly been involved. Paul, we've benefited from some editorial feedback, quite a lot of very helpful editorial feedback from you already in the process of looking at publishing this approach and how it was developed. But I should talk about the WHO advisory group that we've put together on methods, systematic review methods for occupational health, because we know there's a gap of methodologists specifically focusing on occupational health. And this is a group that's formed and has about 30 members at this point, including many members perhaps that overlap with membership of your group. And we look forward to continuing to improve this tool over time. And that membership is essentially open and by invitation. So we look forward to engaging further with others who are also interested in this approach.
Super, thank you very much, Frank. All right, so we'll go on to our next presenter now, or presenters, I should say. So I'd like to welcome Dr. Beth Radke and Dr. Erin Yost, who are epidemiologists and toxicologists, respectively, working at the Center for Public Health and Environmental Assessment at the US Environmental Protection Agency. And they are going to be talking to us about their experience of the US EPA IRIS Program approach to assessing certainty of the evidence as conducted in the recent systematic reviews of human health effects of exposure to phthalates. So I think, Erin and Beth, I'm going to hand it over to you now. If you could start sharing your screen, Erin, and I think Beth is going to be the first speaker in this sort of two-person presentation. Beth, I think you're still on mute.
Oh, can you hear me now?
Can hear you now, yes.
Hello? You can hear me?
Yes, we can hear you.
Okay, great. So you didn't hear anything that I said in comment, right? All right, sorry. I unmuted my phone, but not the Zoom. Okay, so thank you for the invitation. We're really happy to join you today. Erin and I are both part of the IRIS program at EPA, and we're going to try to give you a very quick overview of our systematic review approach, as well as some examples of applying it to both epidemiology and animal toxicology studies. I do want to note that the IRIS program has been in a period of very fast evolution of our systematic review methods over the last few years. So some of the details of how we specifically approach things may be different now than they were when we did these systematic reviews, but the overall process is the same. We just keep refining all the time. So we're happy to get into more detail in questions, or you can reach out to us later. So to start with, you can go to the next slide, Erin. I'll just give some background on phthalates. So phthalates are diesters of phthalic acid, and they're used in many consumer products, and thus exposure is ubiquitous across the life stages. Basically all humans, if they are tested, will have detectable levels of phthalates in their body. So we were working on assessments of essentially all the health effects of phthalates, but today we're going to focus on just a couple of male reproductive outcomes. There's a lot more work that's described in a special issue of Environment International that has been published sort of piecemeal over the last couple of years. And we have a list of all those papers at the end of the presentation if you want to dig into more detail about what we're talking about. So on the next slide, to very quickly summarize what we do after the literature search and screening step, we go through a domain-based study evaluation with 2 independent reviewers and come to consensus ratings for each domain, which you can see on the top table there, both for animal studies and epidemiology studies. We have slightly different domains. And then for overall study confidence based on those domains. And both the domain ratings and the overall confidence ratings feed directly into our evidence synthesis, which is the next step. So on the next slide, our approach for evidence synthesis is adapted from the Bradford Hill considerations. So separately for human and animal evidence, we analyze each of the considerations that you see here. So we think about consistency, effect magnitude and precision, biological gradient or the dose response that's observed in the study, coherence across related outcomes. And then for epidemiology evidence, we also think about natural experiments if they are available, not that often, but sometimes, and temporality. And then we also think about mechanistic evidence within each of these 2 streams if it's relevant to assessing these considerations. There are other steps where we also think about mechanistic evidence. So on the next slide, we have some more detail about how each of the considerations contributes to our judgment about the strength of evidence. So for example, for consistency, if we have similar results in different studies in different populations or different species for animal studies, that would increase our confidence that there is actually an association. And for each of these considerations, we think about high and medium confidence studies receiving more weight. So consistent high and medium confidence studies increases our strength more than low confidence studies. I don't have time to go through all of these, but we have detail here and can provide more later if needed. So on the next slide, we really think of the strength of the evidence as sort of a continuum from, really the evidence is inadequate to draw any kind of solid judgment up to, the strongest possible evidence that we could have that supports an effect. And so we have a structured framework to determine the strength of the evidence. So if you click once more, Erin, for example, the strongest evidence would be a set of consistent higher medium confidence studies where we've reasonably ruled out other possible explanations like bias or chance. And any studies that conflict are weaker, or we have an explanation for why the results are different. And there's also some extra strength coming from, a clear dose response evidence in humans that's observed across populations. There's also other lines of support for animal studies like MOA. And then from there, if you click again, you can see, we go down the strength of evidence. And it's even possible for us to get to, there's strong evidence that there is no effect. We don't see that very often in our assessments, but we do realize that there is a possibility of that. So we have had a lot of discussion at EPA about what to call these different levels. That's still an ongoing discussion, but for the purposes of the papers that we're talking about today, if you click once more, these are the terms that we're using. We're using robust for that top strongest category down to indeterminate for there's really inadequate evidence to make any kind of conclusion. And I did want to note that we considered using GRADE instead of the, rather than creating our own framework. And we like the structured approach of GRADE, but in applying it, we found some pressure points in doing the upgrades and the downgrades for this type of evidence. So we opted to develop our own structured framework. We found it works very well for us over the last few years, but we're always, as I said before, working on refinement. Okay, so then go to the next slide. So normally in the IRIS process, we would then, from the within stream conclusions for human and animal evidence, we would go on to integrate those streams and also bring in the mechanistic evidence on human relevance of the animal findings and susceptibility and coherence across the streams. We weren't able to do that for these papers, so I'm not going to go into it anymore here. So next slide. Okay, now I'm going to go through an example of applying this framework to the epidemiology evidence for anogenital distance and two phthalates, DEHP and DIBP. You can go to the next slide. The literature search was very broad intentionally to capture basically any population, any outcome, any comparator with one of these 6 phthalates that are listed at the top. And on the next slide, you can see that we identified 100 studies with male reproductive effects. And on the next slide, you'll see the 6 studies that had anogenital distance measures and exposure measured in urine, which we consider to be the most valid exposure measurement for phthalates. So on the heat map, you can see our individual domain ratings as well as the overall confidence. And you can see that all 6 of the studies measured DEHP metabolites, 3 of them measured DIBP metabolites, 3 were considered medium confidence, and 3 were low confidence studies. Okay, next slide. So looking at DEHP, the medium confidence studies are on the figure, and all of the studies are in the table. And we can see that the 3 medium confidence studies all showed an inverse association between the sum of DEHP metabolites and anogenital distance. They're not all statistically significant, and the confidence interval for Bornehag et al. 2015 is very wide, so there's some uncertainty there. But we do see this sort of exposure response gradient across the studies, where the studies, as the exposure levels within the population increases, so does the effect estimate. In the low confidence studies, also 2 of the 3 of those also observed an inverse association. So then on the next slide, that we sort of pull all of this together, and you can see we have, similar to GRADE, we have factors that increase our strength and decrease our strength, but it's a little bit less rigid, I guess I would say. And so and the factors that increase our strength we have, and these are driven as much as possible, they're tied to the Hill considerations as I talked about before. We have consistency among the medium confidence studies. There's the exposure response gradient across the studies. We have minimal concerns for bias. These are well-conducted studies. Whereas on the factors that decrease strength, we have low precision in that one study with the largest effect size. So taking all that together, we're considering this to be moderate evidence of an association between DEHP exposure and anogenital distance in these studies. And then in the paper that you'll see, we then also went up to the male reproductive conclusion. Okay, and then on the next slide, just looking at DIBP very quickly, this gives a different picture because we have only 3 studies. 2 of them are medium confidence. 1 of them was essentially null, and 1 showed a non-statistically significant inverse association, and so did the low confidence study. And so if we go to the next slide, we see the table again where, really there's inconsistency across the medium confidence studies that decreases our strength. There really aren't many studies at all for us to be able to probe that inconsistency and see if there are reasons for it that we can explain. And so while there is some indication that there's maybe an association, we're calling it slight evidence. Okay, and so now I think on the next slide, I'm handing it over to Erin Yost to go through an example with animal toxicology studies. Thank you so much.
Okay, can you guys hear me?
Yeah, we can hear you fine.
Okay, great. Okay, so yeah, I'm going to show an example from animal toxicology. And so this is from our paper that was a systematic review of health effects of DIBP exposure, just looking at animal toxicology studies. Okay, so again, similar to the EPI studies, we did a very broad literature search focusing just on DIBP, and we looked at 6 different health outcomes that have been commonly associated with phthalate exposure. But for this presentation, I'll just focus on the male reproductive effects. And so basically we found over 1,000 studies. We narrowed that down to 20 that met our criteria. For inclusion, 16 of those looked at male reproductive effects, and a subset of those looked at effects on testosterone. So that's what I'll be focusing on in the next slides, is how we synthesize the data for testosterone. So this slide shows a summary of the study designs and the study evaluation results for the animal studies that looked at some measure of testosterone in males. So you can see I've got these divided up into gestational exposure studies and postnatal exposure studies. So the gestational studies were any studies that looked at effects in F1 males from mothers that had been exposed to DIBP during gestation. And then the postnatal exposure studies were studies that looked at exposures in young males. So you can see the gestational exposure studies, if you look at those first, we didn't have many concerns about them. We give them good ratings across most domains with some adequates mixed in. The one exception, you can see the study by Wang et al. In mice had a deficient rating for its results presentation, and that's due to, they showed their data for the F1 male pups as an average of individual pups, which is something that's been shown to potentially increase the significance of the results. So we do consider that a concern for bias. But otherwise that study was pretty good. We had a few concerns. So that was the medium confidence rating overall, high confidence for the rest. Looking down at the postnatal exposure studies, you can see that we had more concerns about those. So for example, one concern for bias would be that they didn't provide any information about their allocation of test animals to experimental groups. And that's something that has been empirically shown to potentially bias your results in favor of seeing an effect. So that's one concern for bias. One concern for sensitivity in the postnatal studies is that it appeared from the description of the test animals that the animals may have already started puberty before the study began. So that's something that might reduce the sensitivity to effects on hormones. So, and then one study had a concern for results presentation. So we ended up giving those medium confidence ratings for 3 studies, low confidence for 1.
Erin, you've got 2 minutes, but if you like, I can give you 3 just because you do have a slightly longer presentation and we're doing reasonable on time. So.
Oh, great. Yeah, 3 minutes.
Okay.
Good. Thanks. Okay, so we do try to synthesize data separately for different life stages of exposure when we have data available, and that's because we want to account for potential differences in susceptibility across life stages, and that's something that's especially true for things like hormonal effects, where you can have very specific windows of exposure and sensitivity. So since we had these 2 data sets available, that's how we approached it for the animal studies. So this is showing first the data for testosterone after gestational exposure. You can see that across the studies in rats and mice, we had a very consistent decrease in testosterone with exposure. And in the studies that had multiple doses tested, there was a dose response gradient with increasing effect with dose. So here's our evidence profile table that brings the data together for gestational exposure. Some factors that increased the strength was that consistency across studies and across species. Dose response gradient, a very large effect size in some cases, up to 96% decrease compared to controls. There was support for biological plausibility from mechanistic data because some of the studies also reported gene expression data in the testis of the fetal mouse, where they showed that there was decreased expression of steroidogenic genes with exposure. So that supports biological plausibility. And then, and as I mentioned earlier, minimum concerns for bias and sensitivity. So overall, we consider that to be robust evidence for effects after gestational exposure. Moving on to postnatal, these results were more all over the place. So for the 2 studies in mice, one saw no effect, one saw a decrease in testosterone. In rats, there was a general trend towards increased testosterone, so conflicting results across species. So our evidence profile table that pulls data together for the postnatal exposures. Factor that increases strength is that there is that biological plausibility for effects in testosterone, as we've seen with that gestational exposure data. But decreasing the strength is that unexplained inconsistency across studies, both within the species and across species, as well as the concerns for bias and sensitivity that may have explained some of those differences in results. So our conclusion for the postnatal exposure studies was that there is indeterminate evidence for effects on testosterone, since we couldn't conclude either way what the effect seemed to be in those animals. And if you look at the paper, we do also come to a conclusion for male reproductive effects overall, which we do consider there to be a robust evidence that DIBP is a male reproductive toxicant based mostly on that gestational exposure data.
Thanks, Erin. If you could just look towards wrapping up now, we're just running a bit short on time.
Sure.
Thank you.
Yeah. Lastly, just a plug for our special issue. We just finished publication of the series of papers in Environment International that covers the gamut of methods and systematic reviews for our phthalates project. So we encourage you guys to check that out if you want to see some more information on this project. And I'll wrap it up.
Wonderful, thank you, Erin and Beth. That was really interesting. I don't just say that because I happen to edit these systematic reviews. I should probably actually just clarify that whilst a lot of the research here is being presented has been published in Environment International, we've chosen these presenters not because of the journal, but because we've got two, probably the largest environmental health systematic review projects which have been undertaken, just happen to both be being completed at the same time. So it's just very good timing for this kind of webinar. Beth, I think I have a quick question for you, which we'll probably circle back to in the panel discussion. But you talked about there being a few pressure points when it comes to applying GRADE in environmental health systematic reviews for US EPA. And I was just wondering what sort of pressure points those might be, if you felt comfortable maybe clarifying what they are.
Yeah. So, you know, a lot of this is from a lot of discussion within our group, and not just specific to the epidemiology evidence, but for the toxicology in particular. And so part of it is the rigidity of having to downgrade and not upgrade for the same factors. And I know that some of our group had some issues with the indirectness, and so we can certainly get into more detail about what that looked like, but I know we don't have a ton of time. So.
That's very interesting. Yeah, I think we're just kind of more queuing up an issue for further discussion a bit. So what we'll do now is we'll go to our final presenter before we then return to Holger and Rebecca for comments from a GRADE perspective. So I'm very pleased to introduce German Cano Sancho, and I'm going to have to dust off my French here. He is chargé de recherche at the Laboratoire d'études des résidus et contaminants dans les aliments at the École nationale vétérinaire, alimentaire et d'alimentation, or IRIS, in Nantes in France. He will be speaking on his experience in integrating mechanistic data and use of the National Toxicology Program, Office of Health Assessment Translation Certainty Framework in systematic reviews of the effect of organochlorine exposure on risk of endometriosis. So, German, if you'd like to share your slides.
Thanks, Paul. Can you hear me well?
I can hear you very well indeed.
That's perfect. Thank you so much for your nice presentation in French. It's excellent. I'm gonna share. So thanks very much also for the rest of organizing team to let us the opportunity to share our experience on systematically integrate the evidence on endometriosis and organochlorine chemicals. First of all, I would like to say that I don't have a conflict of interest on this research. We are fully funded by public organizations, and we don't participate on regulatory decision making. We are independent scientific units that provide independent research. So what's endometriosis? Actually, nobody knows very well what's endometriosis, but we know that touch a lot of women worldwide in reproductive age. And it's characterized by the presence of endometrial tissue outside the uterine cavity that particularly keeps the estrogenic reactivity during the hormonal cycles, and that causes a lot of pain to women, and that's very dramatic impact on the well-being of women. Many factors has been associated to the mobility of cells, including a retrograde menstruation, but other factors has been also associated to implantation of the endometrial lesions, including the environmental pollutants. That was the reason that brought us to conduct a preliminary study in France, a case control study, where we were able to find most of organochlorine chemicals like pesticides, dioxins, or PCBs banned in the 70s, were all found on all women that were measured in 2016. We also established associations with the most severe cases, and that substantiated my research program to develop a novel approach in combining metabolomic and exposomic platforms in order to gain insight on the biological links in between the exposure and endometriosis prevalence. To do that, we conceive an evidence-based framework in order to gather and substantiate the prioritization criteria of chemicals and biomarkers of that novel approach. So we conceive an epidemiological systematic review and also a systematic review on experimental studies that I will expand a little bit more. In the first systematic review, we applied NTP OHAT approach to evaluate the risk of bias and the level of evidence, because it's a framework that I'm more familiar with. And we end up with 17 studies that mostly were positively associated with endometriosis, either dioxins, PCBs, or pesticides. And we were surprised of the heterogeneity of the different biomarkers used, especially many of them were using serum biomarkers that entails a model specification issue related to the specific phenotype of lipid perturbation that is underlying the pathology of endometriosis. Well, overall, we conclude that there is a positive association, but we highlighted the level of evidence was moderate based on the OHAT framework, with serious risk of bias, especially associated to the selection bias, that it's a limitation of endometriosis research, because most of the studies were conducted in clinical settings, and there is a true difficulty of finding confirmed control population. And also the population-based research is lacking in the body of evidence. Also, most of the studies were case control studies, so we could not rule out a high risk of reverse causation that could explain the high level of organochlorines. So this further stimulated our need to conduct a systematic review on experimental studies that basically we extend the protocol towards the in vivo and in vitro models. So we developed the protocol that was published last year, and we developed the PICO statement also considering all organochlorine chemicals in a broad way, because we show that those chemicals are very tightly correlated in human specimens, so we cannot isolate one of them. And the other thing is we are not providing a systematic review for regulatory framework that all of chemicals are banned. So we are mostly interested to gather the evidence to better understanding the underlying pathways and establish a robust conclusion on the causation links. So about the outcomes, we were inspired by the AOP framework and the key characteristic framework for carcinogens in order to identify different experimental outcomes that are very used on endometriosis. So I should highlight the complexity of experimental research of endometriosis because it's a very complex disease to study in animals that only happen in primates. So we find that onset of endometriosis only might be evaluated in very strict models, and other outcomes include the measurement of growing lesions that are implanted in rodents, or in vitro models that are following up the migration capacity of cells. We also consider the proliferation outcome as a basic endpoint to keep the endometriotic tissue alive and growing. In the middle, we consider a list of intermediary outcomes that might help us to establish links between the exposures and the apical outcomes, including the gene markers or cytokines related with inflammation, also the perturbation of steroidogenesis or progesterone resistance, among others. The workflow follow a NTP OHAT approach that was managed by Holger, where we use for synthesis and also to manage the risk of bias assessment, and we then conducted the evaluation of the level of evidence. I will show you some preliminary results. You should take into account that it's not published yet, so some might be modified later on, but I would like sharing with you some of the features that we found and the methodology we use to display the results. I will focus mainly on TCDD, that it's one of the most reported chemical. So to date, we have compiling 17 in vivo studies and 24 in vitro studies. And this is an example displayed by Holger, where we display in a qualitative way the direction of the effect. This is in the case of the onset or incidence of endometriosis or endometriotic-like phenotypes. We have 3 studies on TCDD that were showing a consistent increase, and one on PCB that was not associated with endometriosis. The second apical endpoint is the lesion of growth that was pretty consistent at the higher doses of TCDD, and at the lower doses was not associated with the growth of the lesion in most rodent models evaluated. When we see the other OCCs, we found very inconsistent results. In some cases there is association, other not. But interestingly, in the case of the most toxic PCB in terms of the dioxin-like activity, we find some consistency with TCDD. The proliferation also exhibited very conflicting results, either on TCDD that was not consistent at all and the rest of chemicals, but was in opposite direction of migration or invasion in cells that was very consistent across the different chemicals and in TCDD. Interestingly, in the lower dose of TCDD, we found consistent interaction of TCDD with estradiol. So for the primary outcomes, we move the framework to evaluate the risk of bias, considering the NTP OHAT tool adapted to a specific research question where we classify in the entire approach in the different level of risk of bias. So we consider serious risk of bias in the case of onset, because some studies lack of reporting very important information and was classified in the lower tier. In the case of growth lesions, we consider not likely not to downgrade. In the case of invasiveness in vitro, we consider also serious risk of bias to downgrade the confidence, and similarly also for the proliferation outcome. I will also highlight the analysis of directness or indirectness in that case. In the case of the exposure doses, in the upper part, you can see the panel of doses from epidemiological studies highlighted. The higher dose study that from the asbestos accident, that is far from the rat studies or the rodent studies in the lower panel that are some log scale for higher. So here we consider penalizing and downgrading the evidence of growth lesion in animals because they high dose use. So this is the summary table we use to have the level of evidence for the different bodies of evidence, and we can see most of them were finally classified as moderate, and the case of invasiveness was compensated by the high consistency across the study and keep at high level of evidence. We further continue displaying the different nodes of endpoints connected between them with what we so-call as an evidence network, using a key arrow for connecting in case of positive associations and using the size of the arrow for the level of evidence. This to help us to establish the connection between chemicals and the different endpoints. And in this case, I emphasize the interaction of estrogen with the connecting node with invasiveness in vitro. We do the same for the intermediary outcomes, and we can identify here some AOP-like framework, but it's not that complex, but it's giving us some example of connecting arrows between some intermediary events like the inflammation that was the most important body of evidence that was supporting the relationship with inflammation and invasiveness or in vitro and in vivo. The same for the case of the MPPs that were associated either with TCDD alone or also TCDD with estradiol in the interaction term. And that is a marker of matrix remodulation, and it's a marker also of invasiveness in vitro and in vivo. So we are extending.
And you have just 2 minutes left, okay?
Okay, that's perfect. We are on time. So we have confirmed this network of genes and markers with also the analysis of comparative toxicogenomic database, where we end up with 155 genes on the connecting nodes between TCDD and endometriosis that, as we can see, are overlapping nodes on endometriosis, perturbation of steroidogenesis, or genes associated with the adhesion of molecules. Also, we can emphasize the overlapping genes between TCD, estradiol, and progesterone, as we have emphasized. To finish, I want to thank the huge work of Komodo that is today here with me, that has been doing the most of the work, and the rest of our team and the gynecologists participating in the systematic review and the toxicologist. Okay, that's all for me. If you have any question, I will be very happy to answer you.
Brilliant, thank you, Schünemann. I don't have any immediate clarificatory questions. Oops. So what I might do in order to keep things moving forward is if I invite Rebecca and Holger to provide their responses. So Holger Schünemann is Professor of Clinical Epidemiology and Medicine, Director of Cochrane Canada and the McMaster GRADE Centre. And Rebecca Morgan is Assistant Professor in the Department for Health Research Methods, Evidence and Impact at McMaster University in Hamilton, Ontario. They're going to be providing their thoughts, questions and observations from their perspective as inventors, developers and methodologists working with the GRADE framework and with systematic review. Holger, you're still on mute.
Oh, what an amateurish mistake, but it happens all the time, I think. Anyways, thanks, Paul. I'm great to be here and very glad to participate. As we said before, the idea was to see how these sessions and how the EBTC work fits into or fits with GRADE, how the relation works, or how other frameworks connect to GRADE. And I will just offer a few general thoughts. We will not provide any details on GRADE really, because that's probably not both in the intention of the organizers as well as not possible with the time available. But so just a general issue, and you alluded to that in your question, I think, to Frank, which relates to how GRADE operates. And GRADE is an open working group that has over the last 20 years really tried to move methods forward through open dialogue and also looking at potential criticism, application, as well as fixes of GRADE in a way that has then led to advancement. And one of the I think one of the fortunate outcomes has been that we've developed meetings that take place twice a year in a way that those who work on GRADE-related issues, in particular, if they use the GRADE framework and try to modify it or base something on it, to actually bring that work forward for a full discussion with GRADE working group members. That is obviously, who have many more opinions or interpretations or connections than the two that Rebecca and I can offer here. So I think that's really important. So thinking of Frank's Prevalence work, and you already mentioned that, I think it would be great, right, to look at this in the context of a GRADE Prevalence project group, where I'm sure additional thoughts could be quite helpful. So for instance, how to operationalize certain areas. And in particular, because there has been work on prevalence taking place by Maicon Falavinha, who has applied GRADE in the context of prevalence studies and provided some, at least some initial guidance. So that would be extremely, I think that would be extremely helpful to bring these groups together, ideally in a GRADE project work. So that by introduction. But I had a very specific question, if I did understand it correctly, and that had to do with the expected heterogeneity. So one of the ways that GRADE, as I said, has worked is through operationalization of the judgments on the individual domains. And I wondered, Frank, if I understood it correctly, if you could describe the difference between expected heterogeneity, explained heterogeneity, and unexplained heterogeneity, if you have any thoughts on that, because it looked like something that is not in the GRADE lingo, and I just wanted to understand that a little bit better. If that's something else if that's something different than an unexplained heterogeneity, for which we would be, or we might be rating down. Once again, if we cannot explain the heterogeneity, that might be wrong. If we can explain heterogeneity, we would produce subgroup, in this case, analysis. So that's my first question, perhaps.
Okay, I guess, yes, that's to me to respond straight away, I guess. So, Holger, thank you very much for that analysis and these thoughts. And it's lovely to also meet you because you've been involved in providing some methodological guidance also to our set of systematic reviews. It's lovely to actually be in touch like this. And I think you raised some really important points. So this idea of expected heterogeneity, I thought of it as very specific to prevalence studies, right? Because in prevalence studies, it's quite, you know, in many ways, if you're exposed to some risk factors occupationally, then as I mentioned before, it would be expected that there would be heterogeneity not only between workers, but also across workers, within occupational groups, within industrial sectors and so on. So when we came to the concept of expected heterogeneity, basically we arrived to it from the idea that when we use exposure data in burden of disease studies, we wouldn't necessarily be less certain of use of these data from a systematic review, which of course there aren't many, right? It's surprising that prevalence studies are not commonly systematically reviewed, and there are no standard methods. So it's sort of, it's an obvious huge gap, which also means that there's no such methods for exposure assessment. But anyway, so when we started to think about prevalence studies of exposure to risk factors, it became apparent that often it hasn't been made transparent if assessors thought that this heterogeneity that occurred was actually to be, you know, if you found heterogeneity, would that actually make sense? So would we expect it in the first place? So by adding an upfront assessment of expected heterogeneity, we would basically, you know, force raters to be very clear on, does this occupational risk factor, exposure to this risk factor, vary or not? And then based on that, of course, we can go and assess imprecision and inconsistency. So I think in many ways, you're right, explained and unexplained heterogeneity, these were the two concepts you asked me to relate to expected heterogeneity. I guess expected heterogeneity would be an upfront assessment without having seen the data too well of, you know, as an expert judging if I would anticipate there to be lots of variability in exposure to this risk factor or not. And so later on, if I was to find a high level of heterogeneity, then, you know, this would be explained, right? This would be according to what we expected. So I guess that's the link to explained heterogeneity. And if we find the opposite, it would be unexplained heterogeneity, but it's a bit more complicated once you start thinking through the various options that you can have. So what you can see in this approach is that basically for inconsistency and for imprecision, we have two different sets of considerations based on the level of expected heterogeneity for our assessments, right? So the most obvious is that if we find high levels of heterogeneity in a prevalence study of exposure to an occupational risk factor, then when we come to assess inconsistency, in many ways, you know, it's sort of a little bit counterintuitive that high heterogeneity would then not lead to a downgrading, right? Because normally, I guess, high heterogeneity almost always leads to a downgrade, right? So I think what we do with this additional step is basically just give full transparency from the beginning and upfront assessment of whether we expect heterogeneity, how we expect heterogeneity to behave. Yeah. I don't know if that's enough, but yeah.
Well, yeah, no. So thanks, Frank, for that answer. I think it's a really important topic, and we have a little bit of time. It's one of the issues that came up that I think relates to heterogeneity or inconsistency throughout many different types of assessments. The principles are always similar. That's why it might be worthwhile spending some time on it. So, because one way of thinking about it is if you think of expected heterogeneity, that's essentially what you put into your protocol, right? You would say, okay, here are a few subgroups of the population, combinations of groups, combinations of exposures and populations, where we might see where we suspect there will be differences. These are our limited number, as we typically do it, because if you come up with an unlimited number of explanations, that's also not that helpful. Here's the number of factors that or variables that we will utilize to explore any arising heterogeneity. The way that we would typically do this also in prognosis studies that are very similar to prevalence studies, right? Would be through these assumptions, and we would then say, okay, if any of these any of these subgroups indeed do explain the heterogeneity, then we do present the results separately, which is essentially what you're saying. You then do an assessment. So there's explained heterogeneity. Explained heterogeneity leads typically to a subgroup analysis. And in that subgroup, you would assess inconsistency, imprecision, and even indirectness separately because you have explained the heterogeneity. So I just wanted to confirm whether or not that seems to be congruent. It seems to me that it is indeed completely congruent with how we would have looked at heterogeneity, just that you call that expected heterogeneity, which is one term that one can use, I think, or you utilize it in a protocol type of approach, right? This is what we know before we start the work. Here is what we expect might explain the heterogeneity, right? It is not always the case, because also that is an important finding, right? Because our suspicion may be quite different from what we see, and then we would go into these into the subgroups. Is that an appropriate characterization, or is there still something different?
I think it's very interesting, and I really like how you relate these concepts. And we struggled a long time with giving expected heterogeneity its name, right? But I think it goes beyond just heterogeneity within subgroups. So it could be that one specific occupational risk factor exposure could be just always heterogeneous across, or could be always variable across all occupations. Do you know what I mean? It could be always, for example, if you think about occupational exposure to noise, it could be variable across all workers, right? I mean, there are different levels of noise. So in many ways, it wouldn't only be within one subgroup, but it would be across all populations that we'd be looking at.
Sure.
So, but it's definitely sort of a very interesting concept to compare it with explained and unexplained.
Well, the one thing is,
So I like the...
Yeah, I guess the one thing is that we know there will be differences, but the problem, the issue is, when does it matter, right? And that's when you start your subgroup analysis. So there's always, like in any drug trial, you know, people are not taking their 81 milligrams aspirin every day, really, right? They skip a few days. So there's always, the question is, is there actually any way of categorizing this? Okay. Frank, I'm just going to move on because of the interest of time. So, and probably very helpful to have more in-depth conversation. I will maybe ask one other question and then turn it over to Rebecca. And I wanted to move from Frank, if that's okay, to Beth, and I think it was Beth who alluded to that. So you mentioned the certainty of evidence or quality of evidence, strength of evidence is a continuum, which is what we've, what is completely consistent with how GRADE looks at certainty of evidence, right? It's a continuum, and we're trying to categorize it mainly for communication, and because we, expressing it in a different way might imply false precision, right? If we were indeed trying to explain it as a continuum, the categorization probably just helps with dealing with some of the imprecision around the assessment of the certainty. But so in the matrix, that has always intrigued me, that. And I understand that we are coming from the hazard assessment point of view, but there's this asymmetry between robust evidence for an effect and having only one category that says compelling evidence of no effect, is as opposed to also for no effects having other types of judgments, other types of categories that could be utilized. In other words, if you look at quantitative estimates, your best estimate may be that there is no effect, but for various reasons the research is not good enough. The research is imprecise. You might want to say that there is no effect, that's still your best estimate, but you cannot be fully confident, as opposed to having the evidence the certainty rating in the way that you do it. Any reflections, any comments on that? Is that not as important, or does everything, when you don't have compelling evidence for no effect because of precautionary principles, move into the category of possibly being a hazard?
Yeah, thanks. I think that's a great question. I do think this has to do with our mission at the EPA, and as you said,
And Beth,
can you hear me?
Maybe you can show that. Is it possible for you to show that slide? Because I'm afraid that I may have caught many listeners off guard, and we are not related. You know, they may not recall the slide.
Oh, sure. Yeah.
Showed that
yeah.
so well.
Let me see if I can do it. Or
Aaron, you should be able to share your screen. I think you should still have that ability.
I can share.
Thank you.
So, you know, our mission at the EPA is primarily protective, and so we are interested in determining whether there is a hazard from these chemicals. And
can you just let me know which one I should go to?
Yeah, it would be slide 5. Try there.
Do you see it?
Yeah, go slide 6, I guess.
Slide 6, I think it is. Yes, there we go.
Yep, and then just go forward. Just click twice.
This one?
Yep, that's perfect. Thank you. So, you know, we do think it's important to be able to state when there is, you know, a clear body of evidence that shows that there is no effect. But if in situations where we aren't able to come to that conclusion, functionally, there's not much difference. You know, if there's additional information that could potentially get us into there being an effect, we don't want to say that there's no effect, right? So anything where there wasn't good evidence, you know, or where it wouldn't get into those sort of green shaded, where that there is some evidence, at least, whether even if it's slight evidence of an effect in humans or animals, would end up in that gray, which in this presentation we would have called indeterminate, so, or, you know, inadequate to determine whether or not there's effect. So we don't want to say there's no effect if there's potential for additional information that could bring us to an effect. It's not part of our role to say that there's no effect.
But so if it's not part of your role, I'm just I'm trying to understand this better, and also again relate this back to how we've looked at this in you know, in other exposure effect type of scenarios. Why, if it's not your role, then there is the red category, right? Which you know, red might mean something bad, but in reality that's something good, right? That you have strong evidence, as you said it, for no effect. Again, this has been a debate that has been ongoing, but if that can be assessed, I'm always asking myself, why wouldn't we also be assessing or expressing that we have low confidence in no effect, right? Which may be a result of a assessment, but I guess it is the precautionary principle that that makes
I think yeah, sorry, I didn't mean to cut you off there. I think in practice also it would be difficult to implement. You know, if you have null studies, there could be, particularly, I'm speaking as an, environmental epidemiologist. In many cases, a null study is really difficult to interpret because of issues of sensitivity. There could be exposure level issues or sample size issues or some other sensitivity issue that makes it difficult to interpret the null result. And so I would never want to have a body of evidence that was primarily null, and I would just want to be very confident before I said anything that indicated that there was no effect. So.
Yeah. Well, all that I'm saying is where I'm lost is what you say when you have low confidence in no effect, right? That's where I think that would be very interesting to sort out and understand better, because that scenario may arise, right? Where does that fall? You cannot say. Yeah. You cannot put it somewhere else.
That would fall into that gray area of inadequate or indeterminate.
Yeah. Yeah.
Okay. I'm just going to interject here because we have a couple of questions from the floor, which are perhaps more general.
I have some questions too, though.
Yes. And I'm just going to take a couple from the floor because we have quite a large audience, so we just want to make sure that they're contributing. So basically, we have a question from Nagesh Qureshi. I have to apologize for pronouncing that incorrectly, I'm sure. About how, I think probably this relates mainly to you, German, is how did you evaluate risk of bias and how many tools did you use to come up with your evaluation? And I think it would be interesting also to hear from Erin and Beth as to the risk of bias assessment tools they used as well. And if I could ask you guys to somehow answer that question in 1 minute each to keep the conversation moving, that would be great. So German, if you'd like to start.
Yeah, sure. Actually, we have adapted the NTP OHAT tool, the only tool that we have been for sure using as a guideline, but adapting for the specific body of evidence for epi studies. We obviously adapted the questions for the in vivo studies as well, but also for each endpoint specific. So there are some broad questions that has been answered for each study in terms of experimental studies, but in that case we have several endpoints that has been refined in terms of outcome bias. And we can appreciate that many studies, for example, are following the same trend in terms of reporting. So that can help us to establish the same tool for in a study base, and then we establish the specific heat map for each endpoint exposure base. That's our approach.
Thank you. And then Beth and Erin, obviously, you did a lot of work on the risk of bias or internal validity assessment side. So if you want to give a very quick overview of that. One of you needs to.
Wait, sorry. We can go next from the EPA. So we had a little overview in our slides. If you look at our domains that we use, you can see they're pretty similar to the NTP OHAT domains. There's a lot of overlap with those, but one difference with ours is that we take the approach of separately evaluating risk of bias and sensitivity. And we do that just because that's kind of it can be an important distinction, because sometimes if your only concerns about a study are for the sensitivity, then your interpretation of the data might be a little bit different than if there was a concern for bias. So that's one, I guess, unique aspect of our approach.
Thank you. So Rebecca, I think we've got, sorry, time is suddenly running short, but you have time for a question, I think, to our participants, panelists.
Right. So German, not to leave you out, I had a question about your evidence profile slide. I thought it was great that you included that in your presentation. And I'm hoping Camilla will bring that up. I just sent her a note. I think it's maybe the second from last or third from last slide. What I noted about it, because, you know, we've really in this talk and the one preceding it, we've been going over, you know, how do we handle multiple streams of evidence, right? And it brings, you know, it expands our scope, it expands, you know, the resources needed, and and the work needed to go through all of the evidence. And then also, how do we present that evidence? And one thing that I noted in your evidence profile is you're working with, you know, our standard grade domains. And again, Camilla, if you have that presentation, it may be easier to see. But you're also adding this domain at the end, talking about consistency, right? So you have this pairing between an issue of indirectness within the human data, I believe, which is then picked up again, I think it's second or third from last, within this domain of consistency between the human and the animal streams. And I think I wanted to hear from you, German, kind of the feedback that you received about having these two domains, and then if you had explored just, you know, not rating down for indirectness within the human data, and providing an explanation with the supporting evidence.
Am I on the right one?
I think it's towards the end. It's maybe, you know, second from last or third from last.
Okay.
But you probably, German, you know better. I'll let you answer.
Yeah, I think I share a different presentation, but it's probably before. It's 10 slides before. It's the profile, the overall profile table. Goes, Rebecca?
It was, yeah.
Yeah, it's just before.
Schünemann, do you want to share yours so then you have?
Yeah, for me.
Okay, yeah.
If I can, I'm not sure if I can.
Yeah, you can now.
Okay.
And I don't mean to take time. I just wanted to get your feedback on that use of the table in the presentation.
Here you're raising very important questions. One, it's the cross-stream evidence integration. That it's a step that we have not addressing yet, because till now we have been sharing the evaluating the integration in each stream independently, but we consider the indirectness of the body of the endpoint as a factor to increase or decrease the consistency, as considered within the NTP OHAT framework, that it's a dual factor. Let me get this one. Is this one?
Yes.
So here we have in the NTP OHAT framework, we can rate both the unexplained inconsistency and consistency as upgrading and downgrading factor. So it's a factor that can be evaluated in a dual direction. So in terms of cross model evaluation or cross species or integration of different streams, you saw that actually we have not evaluating in a stream way, but the outcomes were mostly stratified in primary and secondary outcomes, regardless of if they were in vivo or in vitro models. And we consider that all body or outcomes were applied to the research of endometriosis, considering the limitations. So mostly we consider that is the best that we can do it in experimental research. We agree that the whole gold standard model is in monkey studies, but there are many endpoints that cannot be evaluated. So we consider that all studies are the best that research can get right now. So probably this evaluation can move during the time, and in 10 years, the experimental models might be seen in a different way, but our evaluation today reached this level of evidence. So that was our rationale to evaluate the consistency. So we hope that next step will be the integration of epidemiological stream and the experimental stream, that probably we will address this kind of consistency across different stream of evidence.
Thank you.
Okay, Paul, do you want to talk about the poll?
Yep. So I think we're just about coming to the end of the call. We probably have basically run out of time to address the more detailed question we have here. So I have to apologize to Dawei Tang for not getting to that. We have an audience feedback poll, which is currently live. So you can tell us how much, what you thought about this session. I certainly like to thank our presenters for their excellent talks. I certainly found them very interesting myself, for Holger and Rebecca for their thoughts and responses. Katie, do you have any final comments you'd like to make?
Yes, I just want to join you in thanking everyone for their time and for this discussion. You know, I wish we had a little bit more time to continue. So hopefully we'll have other opportunities to reconnect and connect bilaterally to continue those discussions. But I'd like to specifically thank Paul for doing most of the legwork on putting this together, and Rebecca, Holger, and all the panelists. And Sebastian has been lurking in the background, but he is a backup for Paul in case something happens with Paul's connection. So thank you so much. And this this nice graphic on the bottom of the screen is something that also Paul came up with before Hamilton workshop. And we actually do, it's about evidence integration in case you were trying to figure out what it was. But in case you wanted a t-shirt as a panelist, you can get one. Get in touch with Camila and we'll try to send one to you. But thank you again.
Great. I think also we should emphasize that both GRADE and EBTC exist entirely to promote and develop understanding of systematic review methods in environmental health toxicological research. So if you have any questions at the end of this, you shouldn't hesitate to get in touch with any of us with those. We'd be very, very pleased to hear from you and very happy to engage you on anything that came up in the course of these talks.
Yeah, thank you. Thank you, everyone.
Okay, bye. Bye-bye.
Thank you, all of you. Bye-bye.
Bye. Talk soon.
Bye-bye.